This video is about using Euler's method to find the numerical approximation of differential equations. In other words, Euler's method can only give you the approximate value, not the exact value. First of all, let's talk about the formula of Euler's method used to find the numerical approximation of differential equations. Suppose this is the solution curve. The blue line is the solution curve. We already know this x sub n minus 1 and y sub n minus 1 is the solution. It's on the solution curve. We want to figure out this x sub n, y sub n by using this tangent line. According to the concept of derivative, derivative is the slope of a tangent line. Therefore, since this tangent line is passing through x sub n, y sub n on the solution curve, therefore, we can write down dy by dx equals f of x sub n minus 1 and y sub n minus 1. Then by using this point slope formula, can get y sub n minus y sub n minus 1. The slope, we can use this f, x n minus 1, y n minus 1. Then x sub n minus x sub n minus 1. Y sub n minus y sub n minus 1 equals this state. This is a slope. But x sub n minus x sub n minus 1, you could say equals to this h. So we multiply by this h. Move this y sub n minus 1 to the right side. You will get the y sub n equals y sub n minus 1 plus. Put the h before this slope, f of x sub n, y sub n. Therefore, we can write down the formula. X sub n equals x sub n minus 1 plus h. Then this y sub n equals y sub n minus 1 plus h times f of x n minus 1, y n minus 1. So for the solution curve, if we want to use Euler's method to find the approximate value of a differential equation, you will get something like this. And x sub n equals x sub n minus 1 plus h. Y sub n minus 1 equals y sub n minus 1 plus h times f of x sub n minus 1, y sub n minus 1. Remember, this is the slope because the derivative is the slope of a tangent line. Let's go to guided practice 1. Consider the differential equation dy by dx equals negative xy, where y equals 1, when x equals 1. Use Euler's method with step size 0.1 to find an approximate value of y when x equals 1.5 by hand. First of all, we will put in the value when n equals 0. That's the initial value. We have x equals 1, y equals 1. Therefore, we use this formula for this slope. 1 times 1 equals 1. Then put the negative sign, it will be negative 1. The step size is 0.1. So for x, you just add 0.1 each step. Y part, you will get y sub n minus 1. This is the previous value. Here's 1. So 1 plus 0.1, because that's the step size is h, times this one. This is the f of x n minus 1 and y n minus 1. So we multiply by negative 1. You will get the 0.9. Use these two values to substitute into this function. You will get the negative 1.1 times 0.9. You will get the negative 0.99. So over here, you will get 0.9 from here. Then plus 0.1 times negative 0.99. This from here, you will get 0.801. Then you have 1.2, that's negative, times 0.801. You will get negative 0.961. Keep going, you will get the 0.801. That's from here. Then plus 0.1 times negative 0.961 equals, this is from here, 0.705. Then for negative sign, 1.3 times 0.705, you will get negative 0.917. So keep doing. Here is 0.705 plus 0.1 times the slope. That's negative 0.917. You will get 0.613. So for here, you will get negative 1.4 times 0.613 equals negative 0.858. So 0.613 here plus 0.1 times negative 0.858 equals 0.527. This will be the approximate value of y when x equals 1.5 by Euler's method. To B, solve the differential equation and hence find the absolute error in your approximation. The differential equation is dy by dx equals negative xy. We know this is a separable differential equation. Therefore, we can organize 1 over y times dy equals negative x dx. Then both sides, we will do the integral so that you will get natural log of y equals negative 1/2 x squared plus c. Both sides, we make e as the base. Then you will get y equals e to the negative 1/2 x squared plus c. We will make a equals e to the 6th power. Therefore, we can write down y equals a times e to the negative 1/2 x squared power. Now we know the initial condition x equals 1, y equals 1. Therefore, we substitute this to the function. You will get the 1 equals a times e to the negative 1/2 power. So organize, you will get the a times 1 over square root of e. Multiply by square root of e both sides, you will get the a equals the square root of e. Therefore, you will get the y equals square root of e times e to the negative 1/2 x squared power. Since we're looking for 1, x equals 1.5. So we get the y equals square root of e times e to the negative 1/2, then 1.5 squared. You put into graphing calculator, you will get the 0.535. For the absolute error will be 0.535 minus 0.527. That's equal 0.008.